Hello everyone, welcome to GW Prime Live. Your where is here. Today we'll discuss about the new era of space mobility. Europe has made immense progress in space over the past few decades and has the second largest public space budget in the world with programs and facilities spanning various European countries. However, from a competitiveness perspective, it should be noted that other spacefaring nations, example the US and some of the BRICS, are also investing significantly, especially in launchers. Europe has a strong space SME sector which continues to grow and bring innovative solutions to the space industry, particularly SMEs serving primes in the upstream sectors and database services providers in the downstream sector. To discuss on the new era of space mobility and more, today with us we have the CEO and co-founder of ENI Space, Dr. Daniel Gran. Welcome to GW Prime.
Hi, everyone. Thank you for having me. It's a pleasure to be here.
So, ENI is a Spain-based 5-year-old startup which has recently raised 3.9 million euros after the successful in-orbit demonstration of Athena. So, Dr. Daniel, how are you planning to utilize the investment?
Yeah, thank you. So we raised 3.9 million, mainly from Spanish investors and also governmental investors. And basically, the objective is really to expand the whole company across the board. So we're going to be complementing or cutting edge testing and manufacturing facilities with a lot more vacuum chambers, which is what we use to test our propulsion systems, and more equipment. And this is going to allow us to basically be able to test more, gain more knowledge about the performance of the thruster, iterate on critical aspects that we're still working on, and also to establish an initial quality assurance capability, which is very important because we're now preparing for our commercial expansion of the thruster, particularly for next year. We're also going to be complementing the whole team with new profiles to take on really critical roles. One of the things that we're doing is, we're very committed to achieving commercialization, let's say full commercialization of all the products in the company next year. We're already commercializing some of those products, but we want to increase our sales capability. And as you know, probably in the space sector, this is still a little bit old school in some ways. So we're hoping to bring a new VP of sales, basically, that can consolidate really our commercial roadmap. We're also going to be adding a lot of capabilities to our software team. So our software products right now were the first products that reached a commercial stage. Let's say the software team right now is in charge of tools like 360, which is our main commercial product at the moment, which is a space mobility and mission analysis and design tool. And we're basically going to be complementing that team so that we can really push forward and have this kind of like world-class engineering tool, which both feels and looks great, but is in addition really providing a lot of actionable insights for mission and satellite designers, which is really the objective of the tool. So I would say those are the let's say the main objectives of the 3.9 million euro round that we've just raised.
So, Athena propulsion system's performance has been well received.
Mm.
What is ENI's plan for its commercial delivery?
So Athena, as I said, let's say we're a bit of a hybrid company. So when we talk about mobility, we work both in, let's say, hardware products and as well software products. And this is because we want to complement our hardware products with services that, let's say, make or streamline the process of adopting propulsion systems and also operating them further down the line, right? So focusing on Athena, yes, Athena is a very unique propulsion system in terms of its performance. Maybe to mention maybe three particular KPIs in which we actually think that we will have an outstanding product. One is high efficiency at low powers, which in turn allows for higher thrust and higher specific impulse. For those of you that know a little bit about the propulsion, let's say jargon, this will mean a lot. But it also means a lot of less wasted power, which basically translates to less thermal loads on the spacecraft, which can actually have a lot of impact on the spacecraft design and its operations, right? The second KPI that we're really proud of is its thrust to power capability. Because of this high efficiency that I just mentioned, we're basically able to deliver 2 to 3 times more thrust than the competition for the same amount of power consumed aboard the spacecraft, which I think is really ideal when you're talking about electric propulsion systems. And finally, compactness. electrosprays, which are the technology that we're using to develop Athena, are extremely mass efficient. That means that basically for the same, let's say the same total impulse, which is the same capability to add velocity to the spacecraft, uh, compared to other propulsion systems, we have probably about half of the mass or less. That means that we can pack a lot of punch in a very, very small package. And I think that's great for a lot of our clients. But going back to the question of commercial delivery, so right now we have about 30 million euros in our commercial pipeline, which come from clients that are waiting us to be ready to deliver our propulsion systems. We're still doing a little bit of engineering in that sense to get the technology up to higher technology readiness levels. But the probably the biggest two milestones that are coming up are two additional planned flights. So the flight that you mentioned was actually a flight of a prototype version of the thruster, which happened a couple of years ago. Since then, we've kind of taken a step back and like really focus on the engineering so that we can have a product that meets the quality and standards and requirements of the space sector. So the next two flights, which will demonstrate that, are planned for early 2025, and they're going to allow us to demonstrate the thruster's capabilities in orbit, which means reaching TRL 9, or technology readiness level 9, which is basically the last step that you need to do in the industry before you can start commercializing. So those are basically the plans, and after that we will start delivering probably of the order of tens of thrusters, tens of dozens or dozens of thrusters every year. After which, once we've demonstrated our first initial entry into let's say the market, we do plan to scale to the capability of delivering hundreds of thrusters, probably in 2026 and beyond. We will need probably a little bit of additional investment on let's say on that front, but those are the plans for the moment.
So, while developing Athena, what kind of challenges did you face?
So Athena is a complex product in many ways. Propulsion systems typically have a budget of between 15 to 20% of the total budget of the spacecraft, which means that they're actually one of the most expensive systems aboard the spacecraft. And that's because they are complex systems, right? And electric propulsion systems are, within the propulsion community, like they're some of the most complex systems. In our particular case, Athena is based on a technology called electrospray, which is a very unique type of technology that has a lot of advantages. We've already discussed the KPIs. But that's required a lot of R&D and basically microfabrication and electronics. So we needed to unlock a lot of capabilities there to be able to achieve, let's say, the performances that we expect for the thruster. And that's what we've been working on mainly. The second problem with particularly an electric propulsion system is that even if you get the design, you then have to demonstrate at least a number of hours of operation to make sure that the thruster can actually deliver throughout the whole mission of the spacecraft. At the moment, our internal record is about 400 hours. But we know that commercially we need to demonstrate at least 500 hours reliably to be able to offer, let's say, a competitive product. And that's what we're mainly working on right now. Future versions are intended to reach 1,000 hours and beyond of operation. And I think that will basically allow us to tackle a lot of very different and highly performant missions in the space sector. And maybe just to mention that at this point, only really one company, which is Busek in the US, has actually demonstrated the use of electrospray thruster for a long period in space. That was part of the Pathfinder mission. So it's a very unique technology because of its, let's say, kind of low power, high efficiency combination and compactness. But it's very different from traditional electric propulsion systems, which are based on plasmas. And then it requires a lot of basically technology development on what I've mentioned, microfabrication, electronics, and so on, and even in the way that you actually test the propulsion system. So there are a lot of challenges there. The main one that we're tackling right now is definitely the lifetime of the thruster. But I think we're making a lot of strides, and we kind of like look back at our technology development and how we've kind of been able to fire for initially minutes, then hours, then tens of hours, and now again like that record of 400 hours. So we're pretty confident that we'll be able to reach that 1,000 hour of operation, which is really the commercial target for us.
So, you have recently partnered with AWS for the IRIS program. Tell us more about it, and through this partnership, what is AWS offering?
Sure. So again, we're a very hybrid company. We offer both propulsion products, which are hardware products, and we offer also software products. So Iris is something that we're setting up initially for incubators and accelerators, and that's initially across Europe. But we're very open to expand this to other regions. And the idea here, or how we started this program, was that we felt that we received a lot of value from the space community. It's in Europe, particularly. There's a lot of, let's say, intentions or to allow startups to really pick up the pace and so on. There's a lot of, let's say, public programs, again, incubators and accelerators, and we've had a lot of value received from that. So we wanted to give a little bit back. And what we're doing here basically is offering access to our 360 software tool, which is again a space mission and mobility analysis and design tool for free, up to 15 startups across different incubators and accelerators. And the idea here is that, look, right now they're at the early stage, so they might not be able to really pay for tools, industry standard tools, which are pretty expensive. And maybe the free access tools that are out there are not going to really do the job. So we don't want them to settle for those. We want them to be able to actually have access to a commercial tool that we feel fits well with the industry and meets the standards of the industry. So we give that access for free to those 15 startups this year, and we can provide value to them. This idea of giving back to the community, and then potentially help them to become more established companies in the future. Of course, as a commercial company, we need to think really about like these kind of win-win scenarios. So we believe that if these companies do well because we've been able to help them, however so slightly, then in the future they can potentially become part of our client funnel. So that's kind of like the win that we're also looking for internally. And regarding AWS, basically all of our software tools are deployed in AWS, and we have a kind of like ongoing partnership with them. So what they did this year is they're kind of co-sponsoring the Iris program by allowing us to, or providing us with credits to use on the platform, so that these companies can kind of like use the platform and run the software for free, basically. So they're providing us with the credits on the AWS that's required to onboard these 15 companies throughout the year.
That's interesting that you mentioned about the space tech startups in EU spaces industry. So, what kind of support does they provide, and what role does European Space Agency play in providing the facilities and support?
Sure. So, I mean, I think Europe is a bit of a hard continent for space companies. Of course, you mentioned that the U.S. is definitely leading the commercial race there, and I think obviously other countries like India or China are definitely, let's say, picking up the pace. I think Europe is definitely waking up to the idea of, hey, like we're in a commercial space race, and Europe needs to be able to have commercial companies that are not only delivering on governmental contracts. And this has really happened over the last 20 years. So we have, in a way, been playing a little bit of catch up in that sense. Also, because the European Union doesn't invest as much as potentially the U.S. in space. They do invest a lot, but a lot of the investment is also quite fragmented across the different countries within Europe, right? So remember that we're a block of 27 countries, where everyone has their own space agency or space programs. So all those funds are really actually heavily distributed. So it can be a little bit tricky to work as a space tech company in Europe, but we do have a lot of support, particularly from European Space Agency, which I think tries to provide fair playing ground for everyone in Europe, to develop their own companies. And we've actually benefited greatly from that. We have actually multiple programs, 3 programs that we're running right now with ESA, where they provide both support in terms of engineering, but also financing for the development of, particularly for propulsion systems. At the moment, we're also discussing with them to let's say come in and potentially help us develop further our software tools. So ESA is very interested, and that's their main role, is to, let's say, make a more competitive space industry. And I think in Europe, let's say the European Commission, for example, has a similar role. But we definitely need to probably consolidate a little bit better, like the financing, let's say, frameworks that are, again, very distributed across Europe, and where it can mean that potentially, if you're in a country like Spain, you need to access Spanish investors, which is what we've done in the past round. But it might be more difficult to access, other investors such as German investors or French investors.
So, like you mentioned, the field is probably not stable right now for the European space sector startups. So, what do you foresee in the next 5 years? What is the market going to look like? What kind of new opportunities are they going to offer?
So I think Europe is very conscious that there is a commercial space race going on right now, and that we need to participate in it. And that means having in my opinion, a bottom-up approach. So right now, a lot of the European, let's say, flagship kind of like space programs are top-down. So they come from the European Commission, things like Galileo, Copernicus, right, things like that. Iris 2 as well, which is a constellation that we're going to have, I think, potentially in the future. But I think what really needs to happen here is that there's there's a lot more bottoms up drive, so that basically that people are convinced that the space industry is an industry that is worth it. I believe at the moment it's a $400,000 million market. It's running towards the $1 trillion market tagline. So I think Europe needs to be a part of that, and we can create a lot of competitive companies that are very important in that sector. Of course, right now, I guess SpaceX is really dominating a lot of the market with Starlink and also the launcher market. So I think
Yes.
basically we just need to find a way to compete on that. You also have other Earth observation companies like Maxar or Planet, but I think we really need to start getting some European names in there. And I think also the advent of, let's say, dual use, so basically the defense oriented use of space technologies and space infrastructure is something that I think we've also woken up a lot to, particularly because of the Ukrainian conflict. And I think that's also going to drive a lot of the market in the coming years. So basically, within the next 5 years, I see Europe really taking a step towards competing really with those large constellations, with those large companies that are coming right now from the U.S., but that will start to pop up in other countries as well, again, such as India and China, and really establish a foothold, I think, on the world stage. I think we're doing a lot of catch up right now. I feel that in 5 years we will have catched up, hopefully, to these kind of like more commercial ventures, and then beyond that, potentially Europe might start looking into some business models that are potentially currently not being explored within the space industry, that I think make a lot of sense. Things like cislunar economy, space manufacturing, things like that, where Europe is still a little bit timid, but hopefully beyond those 5 years, once we've played that catch up and we're kind of like at the same level as everybody else, we will start to look into other, I would say, business opportunities.
So, do you have any plans of collaborating with players from other nations, like you mentioned about US, China, India, Japan?
We actually do collaborate already with a number of players from different countries across Europe. So in Europe, let's say the collaboration is, I would say, very let's say there's a lot of incentive to collaborate across countries. So we do have supply chains, for example, that are heavily European based. We do have some collaborations with companies like Neurospace or ISIS Space or Endurosat, which are oriented towards more of our, let's say, commercial goals in the future. But we are planning to expand our collaborations across, let's say, different potential countries. And basically, at the end of the day, when you're looking for a collaboration, you need to make sure that there's a good fit between the two companies, and that mainly the business oriented activities are really aligned. And I think because of what we're doing, because we have these kind of like hardware systems, but also these software capabilities, we are definitely looking to incorporate a number of companies from other countries that might help us potentially maybe make our products better in a different number of ways. So yes, we are very open to collaboration across countries, and again, we're already doing it within Europe. So it's more of a matter of, let's say, now that we're closer to commercializing, moving more towards I would say, the global stage, and finding those key collaborations which are going to make the company become more successful.
So, what new innovations are taking place in the space technology sector? I mean, what are some of the trends that you'd like to mention that you have noticed?
We started the company mainly with a focus on very small satellites, so CubeSats, nanosats, and small microsats, because 4 years ago, I think there was a lot of push from, let's say, to make sure that those systems, those platforms, were really at the forefront of, let's say, commercial business endeavors. I think that's changed slightly right now. There's definitely a push towards, let's say, slightly larger platforms, which are still kind of small, within the order of hundreds of kilograms, but slightly larger than what we were seeing over the last 5 years. So we're now already kind of like pushing towards having more capabilities or more products that can fit on those, let's say, on those larger platforms. So that's definitely a trend that we're very aware of, and we're already taking steps to be able to tackle. In terms of other innovations, I think what I'm really interested in, to be honest, I mean, I think the space industry has really pushed the limit in terms of, let's say, what is physically possible in many ways. So launchers are obviously probably at the limit of what can be done. Spacecraft have miniaturized and then become larger so they can incorporate more functionality. But we're really at the forefront, really always, of innovation and technology development. So I don't see any kind of like big changes in terms of, let's say, what's going to happen in terms of technology development in the future. Of course, companies like us, propulsion is particularly a niche where there hasn't been that much innovation over the last, I would say, 20 years, and that's why we're here. But I think if you look at it, probably everything else, and there are a lot of innovations there, but it's within what's reasonably expected of like technology development cycles. I think what's really going to be interesting, sorry, is the development of new business models. I'm very interested by things like manufacturing in space, what's going to be coming from cislunar economy and things like that. For example, companies like Varda in the U.S., which are manufacturing um, pharmaceuticals in space, right? And I think that's something that's a completely uncharted territory. And these kind of like new business models where you really require companies to take to have the, let's say, the to be bold, right? To be bold and have the capability to kind of like open up a completely new market. And I think space is right for that. I think there's a lot of not doing what has been done before, but actually trying to find new business models, and that's where I expect most of the innovation is going to be coming from. I really like the phrase from MIT, which is innovation is equal to inventiveness times commercialization squared. So commercialization really is the key here, and if you're able to commercialize something where really there's nobody else doing it, then you're leading that market, and I think that's what really brings innovation. So I think commercialization is a big part of that, and I think that's what I think the whole sector needs to be basically focused on.
So, in addition to Athena, you also mentioned about uh, 360 and Go, the
Mhm.
two software tools. Can you please explain a little more about that?
Yeah. So Go is the first software tool that we released to the community. It's actually free of use. Anyone listening can access right now on eni.space, or go.eni.space. They can register, and what it does basically, it's a simulator, a very kind of like simple simulator to understand propulsive requirements for your mission. So it basically allows you to do a setting up of a particular space mission with a space platform in a very simple way, setting up which launcher you're going to be using, and then let's say basically analyzing what requirements you're going to have propulsion wise for the different maneuvers that you're going to be carrying out throughout the mission, whether that's orbit injection correction or orbit maintenance or constellation deployment or deorbiting in the end of lifetime, all those kind of maneuvers. So basically at the end, what that gives you is all the propulsive requirements. And then we also show how Athena will can be configured to meet those requirements. So it's a bit of a double approach. Again, so it tells you in a very early stage, kind of like phase zero or pre-phase zero, what is it that you're going to be needing for your satellite mission. Sorry, and then we tell you basically what we can do, what Athena can do to match that, and that's free reviews. Anyone that wants to take a look can go into our website right now and use it. 360 is our first commercial tool, right? And 360 started as an evolution of Go, where we were trying to get a lot higher fidelity in terms of the analysis that we were able to carry, but also to add a design layer so that basically you could really look into the effects of other subsystems on the spacecraft and the spacecraft operations, the way that you've designed them, on the overall mission capabilities, also from the point of view of space mobility, because we believe that that's our core, but also in general for, let's say, other aspects of the, let's say, the mission requirements, right? And what that's really evolved to right now is a commercial tool that is a general mission analysis and design tool. And again, I'm stressing out design here because a lot of the mission analysis tools that are out there don't really have this design layer. But it also brings a very complete capability in terms of space mobility analysis, which we found that was actually lacking in a lot of the software tools that are out there. And this is a commercial tool right now. We're going to be releasing our next version early next month. Which is when we will start also onboarding the startups from the IRIS program, and we will also have a few clients that are basically waiting on this release to be able to continue using the tool. So we're very excited about the new capabilities that we're implementing here, things like constellation analysis, a lot of streamlining of the existing capabilities that we already had for analysis and design, and in the future we're going to be adding a lot more features. And by the way, I'd like to mention that one of the particular things that we do with 360 is because we're very, let's say, focused on our clients. We have a very focused client client focused approach, what we like to do is kind of co-develop the features that they also might need. So if anyone's coming into the tool, they can tell us, okay, out of the features that you have, these ones are the ones that we're going to be using, but we'd like these other features if possible, so that we can add them to the requirements that we have for our mission analysis. And depending on the priorities that we have and the clients that we have on the tool right now, we can actually prioritize the development of these new features in kind of like a co-development way, so that we can offer them to the client in a streamlined way. And I think that's actually very differentiated from the rest of, let's say, the industry, where you have kind of like commonality packages, but if you want to do something specific, you kind of need to do it your own on your own, and that kind of doesn't is not very efficient, I would say, in terms of resources.
Where do you see the greatest challenges when it comes to space mobility?
So again, we're a space mobility focused company. I think space mobility is something that is there's a lot of things happening right now in the sector. So starting from launchers, which obviously there's a lot of new micro launchers happening right now, and kind of have to compete with SpaceX as a kind of like rideshare launch, or the main go-to rideshare launch. Europe now has Ariane 6 coming along in the future, but again, there's a lot of micro launchers and smaller launchers, and also other heavy launchers in across the world, right? So space mobility really starts at the launcher, but doesn't really end there, right? It's about getting your satellite to where it needs to be, and stay there and perform in the best way possible in its intended, let's say, orbit, right? So there's a lot of conversation regarding OTVs as well, or orbital transfer vehicles, which basically take your satellite from the launcher to the initial orbit at which they need to be deployed. I'm not a big believer in OTVs. We actually did an internal analysis. There's a white paper out there that if people contact us, we can share as well, regarding a cost versus time analysis, really, for deployment of satellites using OTVs. And OTVs are always more expensive than carrying onboard propulsion systems. And even in some cases, they're not really competitive time wise. So I'm not really convinced about the OTV model. I think a lot of OTV companies are also finding that, let's say, there isn't that much of a market for them at the moment, and that people would rather have their own propulsion systems, because even if you get to the first, let's say, initial orbit where you need to be, you then need to maintain the spacecraft at that orbit, and you'll need to do collision avoidance, and you'll need to do deorbiting. So in any case, you're going to need a propulsion system. So then why are you adding this cost layer to the initial deployment? But then the challenge becomes to have the propulsion systems that are really needed for each spacecraft. And what we found there, one of the biggest challenges that we found, is that, look, whatever you think of nanosatellites and CubeSats and stuff like that, like, these things are still being sent to space. I think at the moment, something like 2 or 3 thousand satellites historically of this class have been launched to space, and only 8% of them carried a propulsion system. With all the new regulations in place for sustainability, for deorbiting, for collision avoidance, that's just not going to be able to be the case in the future. Which means that smaller spacecraft, where some companies are interested in smaller spacecraft because they deliver the capability that is needed, and of course in space you really need to be very focused on what class of spacecraft you need to deliver the business case that you want. So you don't want a larger spacecraft or a more heavy spacecraft than when you actually need to deliver your business proposition. Those smaller spacecraft have really kind of not really had access to onboard propulsion systems in the past, right? So that's where we see that 8% in nanosatellites, of only 8% carrying propulsion systems. We're planning to really tackle that and offer a product that can be operated from smaller spacecraft, and I think that will be something that really kind of changes a little bit, and hopefully we will see really an adoption from spacecraft manufacturers on that. And that's one of the bigger challenges that we see. But maybe the second challenge in terms of space mobility is mobility within the space industry is still a very niche sector. So basically, of course, you have big companies like Airbus, Thales, and so on, which have their own propulsion-oriented teams that can help you make a decision on which propulsion system to choose, and also how to operate it later down the line. But if you look at smaller companies, they don't necessarily have those profiles. Those profiles are difficult to find, and there's a big kind of like separation in I think in the market between satellite manufacturers and propulsion manufacturers. So that's where our software tools come in to kind of like bridge that gap in know-how and knowledge. And we're hoping that we're able to be a big player in terms of, let's say, helping, let's say, really smaller companies and smaller teams to externalize that propulsion knowledge or that mobility knowledge in a way that allows them to make really the best decisions when it comes down to their mission, right? So I see mainly those two issues, and I still see them, right? So this is the original issues that we saw when we funded the company. I still think that that's an issue overall today. So from selection of propulsion systems to integration of the best propulsion system possible to then operations in the most optimal way, those are still issues that are plaguing the industry and that are producing basically suboptimal performances of a lot of space missions. And I think that's what we're trying to tackle. At the end of the day, mobility really is a critical aspect of a space mission, and you can't really think about it as an afterthought. You really need to tackle it from the forefront, and by doing that, I think that we will probably see more efficient space missions in the future.
Oh, great. This comes to the end of our conversation. Thank you so much for your time, Dr. Daniel. I'm sure the audience had an amazing time knowing about your company and the future projects that you're working on, and all the very best for that.
Thank you so much, and yeah, again, happy to connect with anyone over LinkedIn. We're always open to looking for new collaborations and potentially new clients too. We're onboarding new companies into our Iris program. So thank you for having us here, and yeah, good luck to everyone out there.
Hello and welcome to GW Bulletin, your daily dose of geospatial news. I'm Sachin Awana and here are the latest happenings. Pospol Private Limited has announced a strategic partnership with the Karnataka Maritime Board. This partnership aims to identify avenues for integrating advanced technologies and sustainable practices across maritime infrastructure, focusing on ports, fishing harbors, sustainable coastal tourism, automation, and environmental restoration, including coral rehabilitation. The Karnataka Maritime Board is a statutory body set up by the Government of Karnataka to facilitate the rapid development and management of ports, inland waterways, islands, and the coastal region. Airbus will take a charge of nearly $1 billion because of poor cost and schedule performance on a variety of satellite programs and will evaluate strategic options for its space business. The company announced after markets closed in Europe on June 24 that it was revising its guidance for 2024 because of both issues with space programs as well as a reduction in commercial aircraft deliveries. That included a charge of $965 million the company will record in the second quarter on its space systems business. In a statement, Airbus said the charge came after a new management team in space systems conducted an extensive technical review of all programs, identifying further commercial and technical challenges on satellite programs. These are mainly related to updated assumptions on schedules, workload, sourcing, risk, and cost over lifetime of certain telecommunications, navigations, and observation programs, the company said. Waymo, an autonomous driving technology company, has announced its autonomous ride hailing service, Waymo One, is now available to everyone in San Francisco nearly 4 years after a similar move in Phoenix, Arizona. Driverless vehicles are expected to drive commercial success for automakers even as regulatory scrutiny remains tight amid concerns of investors about growing investment in the nascent technology. Waymo had started a test service with its research focused program in San Francisco in 2021, which included an autonomous specialist on board for all rides at the time, as it looked to commercialize the technology. NASA successfully launched the fourth and final satellite in a series of advanced weather satellites for the NOAA. Geostationary Operational Environmental Satellite, or otherwise known as GOESU will benefit the nation by providing continuous coverage of weather and hazardous environmental conditions across much of the Western Hemisphere. The satellite launched on a SpaceX Falcon Heavy rocket from Launch Complex 39A at NASA's Kennedy Space Center in Florida. In addition to its critical role in terrestrial weather prediction, the GOES constellation of satellites helps forecasters predict space weather near Earth that can interfere with satellite electronics, GPS, and radio communications. The GOESU satellite goes beyond the capabilities of its predecessor with a new space weather instrument, the Compact Chronograph 1, which blocks the sun's bright light so scientists can observe the relatively fainter solar atmosphere. Hey Technologies, a location data and technology platform, has announced the launch of its fleet optimization software package designed to enhance the efficiency and scalability of fleet management operations. The Hey Fleet Optimization Package addresses the critical demands of the transportation and logistics industry. It offers the location-based capabilities needed to improve delivery times and decrease operational costs by leveraging novel here-built artificial intelligence that helps solve the problem of complex routing operations for commercial fleets. Bowman Consulting Group, a national engineering services firm delivering infrastructure solutions, has been contracted by the state of Oregon to deliver 30 centimeter high resolution natural color and false color infrared orthorectified digital imagery for the entire state. Bowman will leverage the capabilities of its recent Surdex acquisition to acquire digital imagery of approximately 98,400 square miles of Oregon. The deliverables will enhance the capabilities of multiple agency and local governments throughout the state in disaster planning, climate change adaptability, emergency response, land use planning, and public utilities management. The International Telecommunication Union and the West Africa Telecommunications Regulator Assembly have announced a joint declaration aimed at strengthening collaboration on ICT infrastructure mapping across West Africa. Through this collaboration, ITU and WATRA aim to leverage their respective initiatives and projects, avoiding duplication of efforts, reducing cost, and accelerating efforts to connect communities to the digital economy. The joint declaration also outlines several areas of cooperation, including joint advocacy, capacity building, and implementing ITU recommendations on geospatial information. Specific activities will include technical assistance, enhanced network planning, data analytics for decision making, regional integration, and advocacy for transparency. Trajectory Innovation announced that it has signed a business agreement for the production of a hyper-realistic 3D map and the discovery and joint use of national services with the Seoul Metropolitan Government. According to a Trajectory Innovation official, about 10 people, including Seoul City's digital policy officer and Trajectory Innovation CEO, attended this agreement ceremony. Through this business agreement, Trajectory Innovation and Seoul City will continuously proceed with cooperation for the development of national services using the construction of a hyper-realistic digital twin based on a game engine that can reflect various physical information and variables. In particular, during this demonstration period, Trajectory Innovation and Seoul City will construct a hyper-realistic digital twin of a total area of 4 km square in the Yeouido area. They will implement disaster safety, disaster prevention, roads, traffic simulation, and national services and reveal them at the Seoul Smart Life Week held at COEX in Seoul in October. Pixel, a leader in cutting-edge hyperspectral Earth imaging technology, announced that it has officially signed the landmark 350th IDEX contract with the Ministry of Defense at a ceremony in New Delhi today. Awarded as the first ever IDEX Prime satellite grant under the mission Dev Space Challenge, this contract empowers Pixel to develop miniaturized multi-payload satellites for the Indian Air Force. Received as part of the Spark grants by IDEX, this contract will initiate Pixel's efforts to develop small satellites of up to 150 kg for electro-optical, infrared, synthetic aperture radar, and hyperspectral purposes. The 350th contract will enable innovation and space electronics, allowing for faster and more economical deployment, ease of manufacturing, scalability, adaptability, and less environmental impact. That's all for today. See you tomorrow with more geospatial news from around the world.